Support handout number 18. Problem number 1, we want to solve for x using cross multiplying. When you have one fraction equal to another, the cross products are equal. In other words, if you multiply diagonally 7 times x, you get the same thing as multiplying the other way diagonally, 3 times 4, which is 12. This allows you then to quickly solve for x. X is equal to 12/7. Part B, I can do the same thing. 3x times 2 would be 6x. That's going to be equal to 8 times x plus 1. Now I just have some simple algebra to do. Distribute the 8. I will move that 8x over to the other side by subtracting. That gives me negative 2x equals 8, and divide by negative 2, and I'm all done. X turns out to be equal to negative 4. And then similarly on letter C, 2 times the 2x minus 1 must be equal to 5 times the negative 4x plus 3. I'll go ahead and distribute 4x minus 2, negative 20x plus 15. Looks like I need to move the 20x over to the left and the 2 over to the right. And that will give me 24x equals 17. When I divide both sides by 24, my final answer comes out to be 17/24. Problem number 2. I want to solve each equation for x. I am finding approximate degree solutions and only ones within one period, between 0 and 360 degrees. Part A, sine x equals 0.132. It's already in the right format. I need to find all the solutions within one period. Let's draw ourselves a good picture. Sine is positive in the first quadrant as well as in the second quadrant. Think of that as a ratio, so opposite 0.132 over 1, over a hypotenuse of 1. Here are my two possible angles. One of them is a first quadrant angle. The other one is a second quadrant angle. These are not nice triangles, so I'm going to have to go to the calculator. I can see, though, that that smaller angle, that first x, is just going to be sine inverse of 0.132. Sine inverse will find me angles in the first quadrant. Let's go ahead and find that one first. So on the calculator, I need to put myself into degree mode. And now that I'm in degree mode, I can just type it in. I've got sine inverse of 0.132, and that comes out to be about 7.59 degrees. So that's this little angle here. But how will I get the other angle, the second quadrant angle? The key is to use symmetry. This little thing here, obviously, according to the picture, is also 7.59 degrees. In other words, it's another copy of x sub 1. If I want this x sub 2, all I need to do is take 180 degrees, a half revolution, and subtract out the 7.59. In other words, x2 is just 180, take away that x1 answer. Going back to the calculator, I will type 180 minus the last answer, and I get 172.41 degrees. And I'm finished. Remember, it's the symmetry of these pictures that are the key to finding all of the answers. Let's try letter B. I think the first thing I need to do is cross multiply. I've got 29 times sine x equals 5 times 4, which is 20. I can then divide both sides by the 29. And now I have that familiar looking format. Sine x equals sine and a number. The number in this case is 20 over 29. I think my picture is going to be essentially the same. It's positive again, so I have a first quadrant angle and I have a second quadrant angle. My method is really going to be the same. Here's the first quadrant angle I want. Here's the second quadrant angle. I can tell from the symmetry of the picture that the first answer is just going to be found with inverse sine of 20/29. So that'll give me that first quadrant answer. And the second answer, just like before, it's going to be 180 degrees minus that first answer. This little angle here is the same as this angle here. On the calculator, we have sine inverse of 20/29, which gives me 43.60 degrees. And then for the other one, just do 180 minus that. I'll use that last answer there just so I don't have any rounding issues. And I have 136.40 degrees. Once again, we used the symmetry of the picture to find that second answer. Letter C, I also have some cross multiplying to do here. I'm going to have 9 sine x equals 20. And when I divide by 9, I'll have sine x equals 20 over 9. But 20 over 9, that's bigger than 2. 9 goes into 20 more than 2 times. That's impossible. You can't even have a sine ratio bigger than 1. So this is an impossible equation, which means this equation has no solution.